This is one of Pakistan's leading enterprises, equipped with a wide range of machinery. The motorcycle flywheels they manufacture even meet export standards. These square steel rods are the materials used to make the flywheel rings. First, workers feed the square steel into a coil spring machine, where 3 rollers apply pressure to the steel, causing plastic deformation. As the rollers rotate, the square steel gradually bends and forms a circular steel ring. The spiral rings are then taken to a cutting machine, which cuts a gap in the center of the ring, separating the continuous steel rings into individual pieces. The entire process is surprisingly satisfying to watch. The cut rings are placed on a resistance welding machine. When an electric current passes through the contact points of 2 metal surfaces, the resistance generates a large amount of heat. This heat melts the metal at the contact point, and the molten metal fuses under pressure, forming a strong weld joint. Since the welded points protrude, the next step is to grind the weld seams. This ensures the ring surface is smooth and the seams are flush. The ground rings are then placed on a CNC lathe for machining. Following a pre-programmed path, the CNC lathe precisely controls the movement of the cutting tools and parameters to shape the ring to the desired size and contour for the flywheel. CNC machines significantly improve work efficiency. A single ring can be processed in less than a minute. Next, the gear hobbing process takes place. Multiple rings are placed neatly on the workbench and fixed to prevent movement during processing. As the hobbing machine starts, the table rotates slowly, rotating the rings uniformly. When the hob cutter comes into contact with the ring, it cuts gear grooves along its circumference. The hob cutter keeps cutting as the table rotates, gradually forming distinct gear teeth. The cutting depth, feed rate, and rotation speed are all precisely calibrated to ensure the teeth have the correct pitch, height, and shape. After hobbing, the basic shape of the gear ring is formed, but it still cannot be used. It needs to be placed in a machining center to chamfer the edges of each tooth and refine the shape. With the assistance of the machining center, efficiency is greatly enhanced, and within a short time, hundreds of gear teeth are chamfered and shaped. After chamfering, the rings are placed on a chuck, which is rotated by a motor, and a file is used to remove any burrs. Once the burrs are removed, the mechanical processing of the ring is complete. However, its hardness still doesn't meet the required standards, so the next step is blackening. The first step in blackening is to soak the part in a cleaning solution to remove any surface oil and debris, ensuring the surface is clean. This is crucial to achieving a high-quality blackened finish. Next, the clean parts are submerged in a blackening solution, typically containing sodium hydroxide and nitrite as oxidizers. Under controlled temperature conditions, an oxidation reaction occurs on the part's surface, forming a black oxide layer. After soaking, the rings are removed from the solution and rinsed with water to remove residual chemicals. After rinsing, the rings are air-dried in a well-ventilated area, ensuring all moisture evaporates. After blackening, anti-rust oil is applied to prevent corrosion, keep the surface shiny, and avoid rust spots or blemishes. This ensures the rings maintain a good appearance during sale and use, enhancing the product's overall value and market competitiveness. With such meticulous craftsmanship, these blackened and rust-proofed rings, boasting excellent quality and performance, will be packaged and sold worldwide, contributing Pakistan-made strength to the global motorcycle industry.